All right, let's dive in. Today, we're talking about two data structures that are absolutely fundamental to writing cleaner, smarter code. We're looking at stacks and queues. And here's the interesting part. Their real power comes not from what they can do, but from what they can't. It's a cool idea, so let's get right into it. And that really gets us to the central puzzle of this whole thing. Programmers have tools that can do almost anything, so why in the world would you ever, intentionally, pick a tool that limits your choices? It sounds kind of crazy, right? But stick with me, and you'll see it's actually a stroke of genius. So think about a programmer's toolkit. The most common tool for storing a list of things is an array. You can think of it like a Swiss Army knife. It's super flexible. You can add data anywhere, take it out from anywhere, shuffle things around, total freedom. Now keep that idea of flexibility in your head as we look at our first alternative. Okay, let's look at our first example of these powerful limitations, the stack. Its entire philosophy is built on one simple but very strict rule: last in, first out. And here's the difference in a nutshell. An array? Total freedom. Do whatever you want. A stack? Nope. The rules are strict. You can only add new things to the top, and you can only take things away from the top. That's it. The middle is totally off limits. You know, the absolute best way to picture a stack is to think of a pile of dinner plates. If you want to add another dish, you put it on top. If you need a dish, you take one from the top. Trying to yank one out from the bottom? Yeah, that's a recipe for disaster, and the stack data structure just makes that impossible from the get-go. Now, in programming lingo, adding a new item to the top of the stack has a name. It's called a push. You're just pushing a new plate onto the pile. And what about taking one off? Well, that's called a pop. You just pop the most recent item right off the top of the stack. So these two simple actions, push and pop, they create the stack's one unbreakable rule. LIFO, last in, first out. The very last plate you push onto the stack is always the first one you're going to pop off. Okay, so it's a tool with strict rules. Who cares, right? Where does this last in, first out thing actually help us? Well, let's look at a brilliant real-world example, fixing broken code. Oh man, any programmer watching this has felt this pain. You're coding away and you forget a closing parentheses, or you mix up your brackets, and bam, the whole thing breaks. There's a tool called a linter that finds these errors, and a lot of them use a stack to do it in a really elegant way. The algorithm itself is just beautiful in its simplicity. As we read a line of code, we just follow 3 easy rules. Rule 1, we ignore everything that isn't a bracket. Rule 2, if we see an opening bracket, we push it onto our stack. And Rule 3, if we see a closing bracket, we pop the stack and check if it's the right match. All right, let's actually trace the code and see this happen. First, we hit an opening parentheses. Rule 2 says, push it onto the stack. Easy. We skip the other characters until we hit an opening curly brace. Same thing. We push that onto the stack, right on top of the parentheses. A few characters later, we find an opening square bracket. You know the drill. Push it onto the stack. So take a look at our stack now. It's holding a perfect history of the nested braces we've gone into, and the most recent one is sitting right there on top. And now, here comes the magic. We hit our first closing brace, a square bracket. So what does Rule 3 say? Pop the stack. We pop that top item off, and what is it? It's the opening square bracket we just added. We compare them. Is a bracket the right partner for a square? Yes, it's a perfect match. We can discard them both and just keep going. So we keep going. We see a closing curly brace, so we pop the stack. And what's waiting for us? The opening curly brace, another perfect match. Finally, we get to the closing parentheses. We pop one last time, and there's its partner. We've made it to the end of the line, and our stack is totally empty. That's how we know the code is valid. The last in, first out rule was the perfect tool because it mirrored the nested structure of the code itself. So cool. So that is the power of last in, first out. But what if you need the exact opposite? What if fairness is what you're after, where the first one to show up is the first one to get served? Well, for that, we need a queue. And the best analogy is something we all know, a line for a movie. The first person in that line is the first person who gets a ticket. The whole system is built on being fair. So the principle that governs a queue is the opposite of a stack. It's FIFO, first in, first out. The very first item that gets added to the list is the very first item that gets removed. It preserves the order things arrived in. You know, the classic example is a printer queue. You and 5 coworkers all hit print at the same time. A queue makes sure the jobs are handled in the exact order they came in. But it goes way beyond that. Think about a massive website server. When thousands of people try to connect at once, their requests go into a queue. This guarantees that the user who clicked first gets served first. Without that FIFO rule, it'd be chaos. Your request might get stuck behind thousands of others that actually came in after you. A queue brings order and fairness to really busy systems.
Okay, so we've seen stacks and queues in action. Let's circle all the way back to our original question. Why would anyone pick these restrictive tools over something super flexible like an array?
What's the real payoff for giving up all that freedom?
Well, it really boils down to 3 huge advantages. First, these restrictions actually prevent bugs. A programmer can't accidentally mess with an item in the middle of the stack, which would break our whole linter. Second, they give us these clear mental models for solving problems. The idea of LIFO or FIFO gives you a ready-made pattern. And third, they make code that is just elegant and easy to read. When another developer sees you used a stack, they instantly know the logic is last in, first out. You don't even have to explain it.
You know, at the end of the day, it comes down to this core idea. These restrictions are exactly what make them so elegant. The limits aren't a weakness. They're actually the main feature. They force you to write clearer, safer, and more predictable code.
So, we've seen how these patterns show up in our code. My final question for you is this. Now that you know what to look for, where else do you see the logic of stacks and queues working in the world all around you? Thanks for joining me for this explainer.